Friends, now in multi-stage amplifier, the next topic is transformer coupled amplifier. It is again from engineering services objective type point of view, but there can be again 1 mark question in GATE exam as well. In case of transformer coupled amplifier, the transformer is used as a coupling device for coupling of input and output signals of each stage. For example, you can see this circuit. This is the circuit of transformer coupled amplifier, where input signal is applied to the input of the amplifier through this transformer. Similarly, output of this amplifier is taken from collector and that is taken to the next stage via this transformer. Then output of this stage is voltage at this collector, which is taken to the load via this transformer. So the transformers are used for as coupling device among different stages of the amplifier. Such type of amplifier is transformer coupled multi-stage amplifier. Now, interestingly, in case of transformer coupled amplifier, what we find, the main point here is basically the transformer is used for impedance matching of the source. So impedance of this source can be matched with input impedance of the amplifier. So the transformer coupled amplifier are excellent for impedance matching. Fine. That is one typical characteristic of this amplifier. And then here you can see the AC signals are passed by transformer, but remember transformer is what? This is basically so a coil. This is primary winding is a coil, secondary winding is a coil. So it will pass AC signal from this side to this side by a transformer action, but this is winding, the impedance of the winding is almost 0 for DC, so it will allow DC to pass through the amplifier and it will allow AC from this stage to this stage. So DC signals are not transferred from one stage to the next stage. So this will block the DC biasing signals and allow the AC signals to pass from one stage to the next stage. Fine. So now, interestingly, let us talk about the frequency response of this amplifier. At low frequencies, what is the impedance offered by the reactance of transformer? You know, the impedance of the or reactance of the transformer primary side will be omega into LP. So, and if you remember, what is the output voltage of this output of each stage? If you remember the small signal analysis, for small signal analysis it is replaced by short circuit and voltage drop, the collector current into impedance of this is the output voltage of the stage 1. Then impedance of this multiplied by this collector current is the output voltage of this stage. So at low frequencies, the impedance offered by primary of the transformer is low. Why? Because that is frequency dependent, and voltage drop across primary winding at low frequency will be low. So at low frequencies, the overall output voltage will be low, but at high frequencies its gain will go on increasing. If it's rather than saying at high frequencies voltage will go on increasing, input voltage amplitude is same. I'm not changing the input amplitude of input voltage. So what I'm doing, if signal has low frequency, amplitude may be same. So this is one signal having same amplitude but high frequency. So I'm changing the frequency of the signal. Fine. So for low frequency signals, amplitude of the input signal is same. That level is same. I am changing the frequency of the input signal. That is what I am trying to. So at low frequencies, the voltage drop across the primary winding is nothing but this multiplied by the collector current. So if frequency is low, this reactance will be low and voltage drop will be low. So if voltage drop across this is low, that means output voltage is low. So the voltage drop across this is nothing but output voltage of the amplifier, because that voltage is being taken on the output side. So at low frequencies, the output is low, When frequencies are high, its output will be high. So that means at low frequencies, when you reduce the frequency, this is the frequency curve. That is nothing but frequency response. So at low frequencies, gain of the amplifier reduces. Why? Because for the same amplitude of the input signal, the gain reduces with frequency because output voltage is reducing with frequency. If output voltage is reducing, input voltage is kept same in amplitude, that means gain is reducing. So gain of the transformer coupled amplifier is low at low frequencies, and it reduces with decrease in frequency. Fine. Now let us see high frequencies. At high frequencies, of course, gain is high. Gain is high. But at very high frequencies, if you know, the transformer has interturn. If you remember, what do we have? Transformer is simple winding on the primary side, and there is always capacitances between turns of the winding of transformer. So because of interturn capacitances, what will happen? You know what is the impedance of the capacitor or reactance of capacitor? 1 by j omega c. So if you go on increasing frequency, the reactance of the capacitor will decrease. So at very high frequencies, maybe at high radio frequencies, the interturn capacitances start giving low value of reactance, and at very high frequencies again gain starts reducing. So I can say in case of transformer coupled amplifier, at low frequencies the gain is low because of low reactance of the primary winding of the transformer, and at high frequencies gain is low because of interturn capacitances of the winding of the transformer, primary winding of the transformer. But what is there? What is this sudden spike? What happens? At certain frequencies, these interturn capacitance and this inductance, that is what? LC, that forms LC circuit, and LC circuit forms what? Resonance. So at certain particular frequency, this circuit may be in resonance. Fine, because that is capacitor and inductance. So at some frequency, your winding may be in resonance, and at resonance what happens? Amplitude will shoot suddenly. Amplitude of the output will shoot and this gain will shoot. So it will show you the spike in the gain of the amplifier at a particular frequency, which is resonant frequency of the winding of the transformer. So what is happening at low frequencies? Gain of the amplifier is limited by the primary winding inductance, which is known as leakage inductance of the primary winding. At high frequencies, it is limited by the interturn capacitance, and at certain frequency, and of course that is about near high frequency, there will be sudden increase in amplitude because of the resonance in the primary side. Fine. So this will not be offering me the constant flat top type of frequency response like RC coupled amplifier. So this is all about transformer coupled amplifier. If you talk about its advantages and disadvantages, the main advantage of this particular amplifier is nothing but that is impedance matching between input and output. It is suitable at radio frequencies, and there is no collector resistance. So if there is no resistance connected in collector, so there are no losses. So losses in this amplifier are very low, and of course if losses are low, so its efficiency is high. So it has got high efficiency, low losses, excellent impedance matching. But what are the disadvantages? We have transformer, so transformer has its own cost, so its cost is high. Then it does not give the flat top flat type of frequency response like RC coupled, so its frequency response is poor, it's not very good, and it is bulky and costly because of the transformer, so its size will be high because of the transformer. So it's bulky and costly, and it will give you the humming noise because of the transformer. Transformer has a noise known as humming noise, so it gives humming noise because of the transformer. So these are certain advantages. And applications, of course, it is used for impedance matching. It can be used for impedance matching, that is one application, and then it can be used for at high frequencies, because at high frequencies, because at low frequencies we know the gain reduces with decrease in frequency, so it is no it may be used at radio frequencies about 20 kilohertz, fine. And transformer coupled amplifier is mostly used at input and output stages, not in intermediate stages. So these are certain points you may remember, especially from engineering services prelims point of view. There can be questions in engineering services prelims mostly, fine. So in my next video, I will be talking about direct coupled amplifier. So just wait for my next video to come. Thank you very much for watching the video.